During World War II, thousands of weapons were issued exactly as designed, and thousands more were quietly altered the moment they reached combat, not because soldiers wanted to modify equipment, but because certain failures kept repeating, and waiting for approval got men killed. Blades were added where doctrine said they weren't needed. Armor was bolted on after it was banned. Aircraft guns were rebuilt for infantry use. Field telephones appeared on vehicles that were never meant to have them. Most of these changes were rejected at first. Then they worked. What follows are 10 weapon attachments the Army resisted, until battlefield results forced acceptance. These are not secret weapons. They are field-built attachments and modifications, improvised under combat pressure, resisted by bureaucracy, and adopted once results became impossible to ignore. In each case, a small change in hardware forced a larger change in doctrine. Number 10. The M4 Carbine Bayonet. The M1 carbine was not designed to carry a bayonet. Doctrine treated the carbine as a defensive weapon for rear echelon troops, drivers, radio operators, artillery crews. Close combat was not considered part of its role, and a bayonet was seen as unnecessary weight. By 1943, combat reports from the Pacific broke that assumption. Jungle fighting, night raids, and banzai charges collapsed distance to arm's length. Carbine-armed troops began wiring knives to barrels because the alternative was trying to reload or clear stoppages, while an attack closed the last few meters. The Army resisted. Engineers argued the carbine was too light for bayonet work. Procurement resisted retooling production lines mid-war. Combat reports kept coming. By late 1944, the Type 3 barrel band with bayonet lug entered production. The M4 bayonet followed. Okinawa became the first major campaign where large numbers of carbine troops could fix blades as intended rather than improvising. Japanese doctrine assumed American support troops were weak in close combat. When carbine units held with bayonets fixed, that assumption failed. After the war, melee capability became non-negotiable for infantry weapons, shaping later doctrine and designs. Number 9. Sherman Sandbag Armor. After early encounters with Panzerfausts and heavy anti-tank fire in Normandy, Sherman crews stacked sandbags on their tanks. General George Patton banned the practice. His reasoning was practical. Sandbags strained suspensions, increased breakdowns, and offered little protection against armor-piercing rounds. Testing supported that view. Crews did it anyway. Sandbags sometimes altered standoff effects against shaped charges, but inconsistently. Against kinetic penetrators, sand compressed and failed. Still, crews kept piling them on because the act itself mattered. It was a visible attempt to survive the next ambush. Recovery crews cursed the added weight. Final drives failed faster. The practice persisted until a better solution appeared. After the Battle of the Bulge, Patton quietly authorized a different answer: welding salvaged armor plate onto Shermans. The Army would not claim sandbags worked, but it acknowledged crews needed more protection. The factory response arrived as the M4A3E2 Jumbo, reflecting a lesson crews had already learned the hard way. Number 8. The M2 Stinger. The M2 aircraft machine gun was never intended for ground combat. In aircraft, its high rate of fire, around 1,200 rounds per minute, made sense. On the ground, it created immediate problems: overheating and extreme ammunition consumption. Marines still salvaged AN/M2s from crashed aircraft because they wanted suppression beyond what standard infantry automatics could deliver against fortified positions. By 1944, Sergeants Alex Grevich and Harold Little built man-portable conversions using a BAR bipod, an M1 Garand stock, and a solenoid trigger. Only 6 were made. On Iwo Jima, Corporal Tony Stein used one to suppress multiple pillboxes under direct fire, making repeated trips to the beach for ammunition. He was later killed and awarded the Medal of Honor. The Stinger overheated quickly and burned ammunition at a punishing rate. The Army never approved it. Yet Japanese defenders, accustomed to slower infantry fire, faced bursts of suppression that disrupted bunker coordination in ways standard weapons could not. The Stinger vanished after the war, but the principle, maximum suppression at squad level, helped shape post-war automatic weapon doctrine. Number 7. The high-standard HDM suppressed pistol. The OSS needed a suppressed pistol for covert operations. Bell Telephone Laboratories developed an integral suppressor for the high-standard .22, reducing report to around 77 decibels. The legal complication was ammunition. The Hague Convention required jacketed rounds, while .22 LR was typically unjacketed. The OSS addressed this with special jacketed ammunition while accepting the weapon's real purpose. William Donovan demonstrated the pistol to President Roosevelt in the Oval Office, firing into a sandbag while visitors outside heard nothing. The suppressor relied on brass mesh and baffles that wore out after roughly 200 rounds, turning maintenance into a supply problem. German security forces documented silent killings across occupied Europe without clearly identifying the mechanism behind them, giving the weapon psychological weight beyond its tactical footprint. The HDM remained in US inventory for decades, and its concepts influenced later suppressor designs. Number 6. The Vampire Infrared Night Scope. German engineers fielded early active infrared aiming with the Vampire system. Mounted to the STG-44, it paired an infrared spotlight with an image converter, enabling engagements at night out to roughly 200 meters. The system worked, but it was heavy, over 30 pounds, with batteries, and battery life was measured in minutes. It required dedicated operators and parts that late-war Germany struggled to supply. Around 310 units were deployed in the war's final months. Allied troops reported night fire linked to non-shining lights, and the psychological effect often exceeded the limited number of deployments. Captured examples directly influenced Allied development. The USM-3 sniper scope followed, and the broader legacy is unmistakable. Night vision became a permanent expansion of combat time and tempo. A pattern is clear. These attachments solved problems doctrine had not admitted existed. They were pushed forward by necessity, not paperwork, and accepted only after results overruled objections. Number 5. The Cullen Hedgerow Cutter. Normandy's hedgerows trapped armored movement. Tanks that tried to climb exposed their bellies. Infantry entering gaps met pre-sighted German fire. At a planning meeting, a soldier suggested welding teeth to tank fronts. The idea was laughed at. Sergeant Curtis Kulin built a prototype anyway, using salvaged German beach obstacles. The cutter's prongs did not carve the hedgerow so much as pin the tank's nose down, letting the tracks drive through without lifting the belly plate into danger. On July 14, 1944, General Omar Bradley watched a Sherman burst through a hedgerow without exposing its underside. Within days, hundreds of cutters were produced. Before Operation Cobra, a majority of First Army tanks carried them. German defensive geometry in the bocage depended on predictable gaps. When Shermans began breaking through at unexpected points, that geometry collapsed. A simple welded attachment changed the terrain's meaning. Number 4. Field welded Sherman armor. After sandbags were banned, crews turned to welded plate. They cut armor from knocked-out Shermans and welded it to glacis plates and turret faces. Ordnance objected over metallurgical compatibility and stress cracking, and those risks were real. Crews learned quickly that armor-grade steel mattered. Ordinary structural steel did not. As results accumulated, the practice spread. By early 1945, Third Army tacitly authorized salvage and weld programs, and some units organized cutting and welding teams between engagements. German gunners relied on familiar Sherman weak points. Field-welded armor disrupted that experience, forcing different aim points and changing engagement outcomes. The post-war legacy was clear. Modular and applique armor became a design expectation, not a field improvisation. Number 3. The M7 Rifle Grenade Launcher. The M1 Garand initially could not safely fire rifle grenades without adaptation. John Garand's M7 launcher solved the problem by attaching to the rifle and venting gas to protect the operating system. Early fielding was messy. Launchers were lost, lock screws failed, and grenades could stick. The system demanded correct blanks and gas lock modifications. Without them, rifles could be damaged and operators injured. Despite the issues, the capability was decisive. Infantry could now attack bunkers, vehicles, and concentrations at ranges far beyond hand-thrown grenades, around 200 yards, changing how squads approached strong points. German defenses designed around short-range grenade threats had to adjust. The M7's lineage ran forward into dedicated grenade launchers and under-barrel systems that later became standard infantry tools. The last two are less about firepower than coordination and sight, two areas where small attachments changed survival rates. Number 2. The Tank Infantry Telephone. Infantry and tanks often fought as separate systems because they could not communicate. In the Pacific, crews mounted field telephones in waterproof boxes on tank hulls so infantry could speak directly to the crew. The value was immediate. Fewer misunderstandings, fewer crushed or abandoned infantry, fewer tanks driving blind into threats infantry could see. Ordnance resisted standardization at first, calling it a unit expedient. The modification spread anyway across theaters. Crews fabricated mounts from scrap and routed wiring through existing ports, later improving connections to reduce vulnerability. Eventually, the VIA one-tank infantry phone was standardized after thousands of improvised examples proved the concept. Modern armored intercom and external phone systems trace directly back to these boxes. Number 1. The periscopic gun sight. Early Sherman struggled to exploit their guns' range because sighting systems limited what gunners could see and reliably hit. Tank destroyers demonstrated that magnified periscopic sights linked to the main gun improved first-round hit probability. Ordnance moved slowly, early linkages were fragile, mounts flexed under recoil, and alignment drifted. Field units reinforced mounts, welded supports, and installed salvaged optics where possible to stabilize the system. As improved designs reached production, crews could engage faster, at longer range, with higher accuracy. The advantage was not only in gun or armor, it was in the gunner's ability to see and aim first. Modern fire control systems are more complex versions of the same requirement. Stable, aligned sighting under recoil and movement. These 10 attachments came from the gap between doctrine and reality. They were resisted, improvised, and adopted because combat forced the issue. They cost time, weight, and maintenance, but bought capability when it mattered. In war, the fastest innovation usually comes from the people closest to failure.